In this lesson, we're going to take a look at something called unit pricing. This is fairly important if you're buying stuff that comes in different amounts to make sure that you're getting the best deal possible. I remember years ago, I honestly can't remember off the top of my head, but I went into a fast food place that sold chicken nuggets. It was not actually McDonald's, but it was a place that sold chicken nuggets. And they had 6 packs of nuggets and 20 packs of nuggets. And I looked at the prices and I said, does anyone order the 20 pack of nuggets? And they said, yeah, all the time. And I was like, why? They said, well, sometimes people are hungry. And I said, did you realize that you can buy 4 6 packs for less than a 20 pack? I said, is there a sale or something on? Like, is a deal on this? They're like, no, these are regular prices. So if anyone had paid attention, they could have gotten 24 nuggets, 4 6 packs, for less than the cost of one 20 pack. So you get more nuggets for less price. That's the regular pricing. There's no reason to ever buy a 20 pack. But unfortunately, most people don't pay attention to this. Now, I will point out that also a lot of times, if you look at things, they price things with numbers that are difficult to actually compare. So, for instance, cases of pop used to be 12s and 24s. Now, what's becoming more common is 12s and 32s. And it's because 12 and 32 are not nice numbers to work with. They're not like before when it was 12 and 24, the 24 was exactly double. But now that it's 32, it's like two and a bit, and no one can really do the math in their heads, so they don't really see how much the pricing is. Because of this, we often do something called unit pricing, which is figuring out how much it is for some amount of something. Now, there's actually 3 ways that we can do it. We can do something called discrete units, which is if you're buying something like, for instance, in example one, buying batteries, we just talk about the price per battery. Now, with foods and beverages, what we usually do is we don't talk about a unit as being like a can of pop. We talk about it as being a certain amount. And the default amount that we tend to use is 100 grams for solid things like foods and 100 milliliters for liquid things like beverages. So 100 grams is just ballpark about a quarter pound. So if you know what a quarter pound hamburger is, it's about that amount of meat. And 100 milliliters of liquid is actually not that much. A can of pop is 350, so it's about a quarter of a can of pop, which is pretty small actually. But by comparing all of these things to the same, regardless of the size of the actual package, we always say how much does it cost per 100 grams or how much does it cost per 100 milliliters. We can compare different size packaging to see which one is the better deal. So rather than talk about this too much more, let's actually just jump into a couple fairly straightforward examples. The first one we'll look at is packs of batteries. So we can get 4 AA batteries for $3.59, or we can get 6 AA batteries for $5.49. Which one of those is the better deal? Now, our brains usually, because this is normally how things would be in a perfect world, usually the more you buy, the cheaper it is per item. But sometimes places take advantage of that and actually hike the price when you buy more because they know they're going to sell them because you assume it's a better deal. That was the case of the chicken nuggets. But let's actually do the math and see which one of these battery deals is better. So what we do with unit pricing is always figure out the price per unit. So we always do price, in this case 359, divided by the number of units, in this case 4, and 359 divided by 4. It works out to be 0.8975, which I'm just going to write as 0.90. So it's essentially 90 cents per battery. Now, if we do this for the 6 AA's, that would be 549 divided by 6. 5.49 divided by 6 is 0.915. I'm going to actually round that off to 0.92. And as it turns out, the 6 pack of batteries, they're actually slightly more expensive per battery. So it's not a better deal. It's very close. It's like close enough that it doesn't really matter. But knowing how to do this actually can save you money, because I've seen examples where the larger packs could cost you 20 or 30% more, but because the numbers are so weird and so hard to do in your head, people just assume it's a better deal. All right, so that one's pretty straightforward. If you're working with discrete units like batteries, you just do the total price divided by the number of items, gives you the cost per item. If, however, you're dealing with things like foods, and I'll use potato chips as an example because this is actually a really good place where they put numbers on the bags that are so weird that they're very hard to compare with one another. So here's three real sizes: the 270 gram bag, the 454 gram bag, and the 675 gram bag. None of those is a nice multiple of the other. So it makes it very difficult in your head to compare these. Now, I'm going to point out something just for interest's sake. You may actually see the number 454 gram fairly commonly for foods, which seems weird because it's such an obscure number. And the reason that 454 is actually used a lot is because it's exactly 1 pound, or at least to the closest gram, it's 1 pound. So anytime you see something that's 454, it's just because it's probably an American item that they produce by the pound, and then when they ship to Canada, they put on the Canadian unit of measurement, which is grams. So you'll see butter comes in 454 grams and so on. It's a fairly common number to see with food. Okay, so let's figure out which one of these is best. Now, unfortunately, we're not going to do the price per gram because that's going to be too small. It's going to be less than a penny per gram, and then it becomes really hard to work with. What we always do is price per 100 grams. So the price part's easy, the $1.49. Here's how I want you to think about it. How many 100-gram piles of food could you make with 270 grams? Well, you could make 100-gram pile, and then a second 100-gram pile, and then not quite a third 100-gram pile. The exact number of 100-gram piles you can make is 2.7. So basically, all I'm doing is taking the 270 and dividing it by 100. So it's got 2.7 units of food. And we're always going to take the number of grams divided by 100. If the number happens to be given in kilograms are 1,000 grams, then we can do the same trick. How many 100-gram piles can we make? So with this one, we just get $1.49 divided by 2.7 is 0.552. I'm just going to round off to the closest cent. So essentially 55 cents per 100 grams. If you want to put that there, you can. Just to remind yourself, it is per 100 grams. I'll put it on these just again to make sure that you remember that's what it's actually representing, is the cost per 100 grams, not the cost per gram. The next bag of chips, the 1 pound bag, is $2.49. Now 454 grams is going to be 4.54 100-gram portions. 249 divided by 4.54 is 0. Now it's 0.548, which rounds up to 0.55. Okay, so for those two, it turns out that the price per gram is about the same. So it doesn't really, like, one's not a better deal than the other, but a lot of people will buy more of something because it's a better bargain, regardless of whether they actually want more. So don't feel bad about getting the 270-gram bag if you're not that hungry, because you're not losing money. It's still a good bargain. It's exactly the same bargain, in fact. Well, let's think about, before we even get this, let's take a guess here. Is the 675-gram bag going to be a better deal, the same deal, or a worse deal? If you're having a hard time figuring that out in your head, it's because, again, the numbers are chosen to make it difficult. If it was exactly twice as big as the small bag, it would be easy. If it was exactly twice as big as the medium-sized bag, it would be easy, but it's not. So here we're going to take our cost, $3.29, divide it by the number of 100-gram portions, which will be 6.75. And 329 divided by 6.75 is 0.487, which will round off to 0.49. Okay, so that's 49 cents per 100 grams. That is a little bit cheaper. It's about 10% cheaper than the other two sizes of bags, so it is a better deal. However, if you're not that hungry, maybe you only need the 270 gram bag. So even though you're paying slightly more per 100 grams, you're still only paying $1.49 instead of $3.29. So you decide which one is better for you. If you're going to buy them and keep them at home and eat them over a week, then yeah, get the big one. It's a better deal. Okay, same trick with liquids for beverages. Instead of doing 100 grams, we're going to do 100 milliliters. So here we'll compare a case of pop, a can of pop, a case of 12 cans, a case of 24, and a 2-liter bottle. Now, I should point out that for A, B, and C, if we really wanted to compare them, we could just figure out the price per can. That would be kind of easy. But as soon as we bring that bottle in there, it doesn't work out as nice. So we're going to do cost per 100 milliliters for these as well. So if you go to a pop machine, like a vending machine, and get a $1 can of pop, $1 divided by 3.55 units. Again, we're not doing grams, it's units of 100 grams, or 100 milliliters, sorry. So 1 divided by 3.55, that works out to be 0. Now this one, I think I'm going to keep one more decimal place, and I think you'll see why. 0.282 cents per 100 milliliters. Or sorry, $0.282, 28.2 cents per 100 milliliters. Now a case of pop, well, it's $4.99. That's the top number, no problem. The bottom number is 12 cans, each of which is 355 milliliters. So I'm going to do 3.55 times 12. Now just be careful when you're doing this in your calculator. What you might want to do is put brackets around the bottom, or I'm going to actually do it this way on purpose. I'm going to actually just calculate the bottom first. 3.55 times 12, because this one often yields a bed mass issue. The good news is if you get this wrong, the answer should look ridiculous. Like it should work out to be like $8 per 100 milliliters or something crazy, or like 0.03 cents per 100 milliliters. Whereas we kind of have an idea what it should be. Okay, so a 12 can case of pop is actually 42.600 milliliter portions. And if we do the math on that one, 499 divided by 42.6 is 0.117. So 11.7 cents per 100 milliliters. So if we compare that to our single can of pop from the vending machine, we can see that the vending machine pop is super expensive compared to the case of pop, individual cans. So yeah, which makes sense. Getting anything out of a vending machine is usually hugely expensive. Now, if we want to do this one, 24 cans of pop for $7.49. I'm going to do a little bit of a shortcut on this one. Since I noticed that 24 cans is exactly double 12 cans, I'm going to have exactly double the portions. So instead of 42.6, I'm going to double that and write down 85.2. If we didn't have that trick, we would just have to do 24 times 3.55, and that would work out just fine. We get the same number. But why not use a trick when we have one? So 749 divided by 85.2. This gives us $0.088 per 100 milliliters. So 8.8 cents. So even that is a pretty decent deal compared to the 12 can case of pop. Makes sense. We got twice as much and it was only 1.5 times more. Now predictions. Is the bottle going to be a good deal or a bad deal? It's really hard to tell because again, the units don't work out as pretty. Well, let's see where it falls. We got Just before we do this, I'm just going to make a little note here. Oops, that's not what I wanted to write. I wanted to write 2 liters. 2 liters equals 2,000 milliliters. So knowing that, it's $2.19, and 2,000 milliliters is 20 100-milliliter portions. So just divide the 2,000 by 100. And 2.19 divided by 20 is 0. Rounds off to 110. Okay, so basically it's a little bit better than the 12 can case of pop, but not quite as good as the 24 can case of pop. So if you want the best deal of these 4 options, it's definitely your case of 24. If you're looking for something a little less than that, whether you buy a 12 can case or a 2-liter bottle, you're paying about the same each, a little bit more for the 12 cans. And the vending machine sucks. That's generally true. Okay, so that's basically how we approach these. If it's discrete items, just do the cost per item. If it's food, let's do it per 100 grams. And if it's liquids, beverages, let's do it per 100 milliliters. Some practice problems there. Give them a shot. If you need my assistance, let me know. Otherwise, the answers are at the bottom of the sheet. Hopefully they're correct. And yeah, good luck. Let me know if I can help you.